Welcome everyone. I'm very excited to be here today to talk about how to approach threat modeling. My name is Darren Boyd. I'm a Principal Security Solutions Architect working with our customers large and small across Australia and New Zealand. Today we'll be covering threat modeling. Why do it and what is it? We'll be talking about some areas you really want to focus on to set yourself up for success when you embark on integrating threat modeling into your organization. And finally, we'll cover the steps involved in performing threat modeling, and we'll walk through a pretty small worked example just to bring it to life. To begin, we should ask ourselves the question, how do security vulnerabilities get introduced in the first place? Well, it comes from code and config that we write as humans, and the way we deliver that is through our software development lifecycle. Fortunately, within the software development lifecycle, there are many areas that we have opportunities to identify these issues. So working backwards from a live system, you could find out about these security issues as a result of disclosures from security researchers, be them responsible or not so responsible, or through a bug bounty program if you've embarked on that. During deployment, you may have a number of automated security checks that you conduct as you deploy through your various environments, ultimately to production. So this represents another chance to detect security issues. During test, dynamic analysis or penetration testing is a very common approach for detecting these issues. In build, you're often doing code reviews of each other's work and using tools and capabilities to do static code analysis. And of course, in design, we have threat modeling. So there are a number of ways within your SDLC that we can detect and solve issues. So you may be asking yourself, why have we selected threat modeling given the large number to choose from? Well, the answer is because the cost of mitigating threats actually goes up exponentially the later you find them in your software development lifecycle. So this is where the shift left notion comes from, and it's really better to find and mitigate issues within security as early in the process as possible. This is when you're in the headspace of creation and design, and it's very simple for you to make design alterations that won't result in a lot of rework in the future. And that is why I'm recommending that threat modeling is really something you want to invest in, because it's in those very earliest stages of design. There are three basic phases of threat modeling, and they're really more like questions that you would ask yourself. What are we building? What can go wrong? And what are we going to do about it? These are very broad questions, and they can be very, very deep and very, very specific. And we'll go into into those in a moment. But before we embark on asking these questions, you really do want to set yourself up for success. What I'll be sharing with you now are some observations that I've witnessed where organizations have been successful in adopting threat modeling at scale and what they've done to make that possible. First is assembling the right team. Threat modeling is a team sport. It requires a number of diverse perspectives and experiences to get a balanced outcome. Right here in the middle, we have the AppSec SME. This is the application security subject matter expert. This is the persona with the greatest expertise and experience with doing threat modeling and is an expert in the application security domain. They will then be complemented by a number of other personas. So we have the business persona, who's actually owning the business outcome. The reason we implement change in our software is to deliver a business outcome. This persona is intimately familiar with the functional and non-functional requirements, and importantly, the customer's expectations of what's being delivered. The developer persona is the persona who is actually performing the build. This is the persona who has been most intimately involved in the design to date and any design decisions that have been made to this point, and they'll ultimately be delivering the outcome requested from the business persona. On the other hand, we have the adversary persona. This persona is focused on being highly critical of the design, looking for chinks in the armor, looking for vulnerabilities that they could exploit to carry out an attacker's goals and motivations. They're taking a very adversarial and attack-centric view. Counter to that, we have our defender persona. The defender persona is primarily looking at the attacks being developed by the adversary persona and determining what possible mitigations could be put in place and ensuring that possible mitigations are not overly onerous in performing the ongoing security operations and support of this application or change. What is really crucial to understand is whilst you see 5 different images of people here, these personas do not need to be individual people. A single person can carry the viewpoints of multiple personas. It's really just to push the point that we need to look at threat modeling from multiple perspectives. And all of these perspectives should be seen as equal in value. This is to drive an appropriate balance between security, functionality, and actually delivering that business outcome. The next tip for success is to drive for consistency. When we talk about consistency, we're talking about the consistency of the threat modeling exercise and its outputs. Here we're talking about the methodology that's used, the format, the look and feel of the outcome, and the degree to which you decompose your application into smaller parts to perform threat modeling. And we'll go deeper into decomposition a little later. But the reason you want to drive for this consistency is that it allows you to reuse your threat models in a way that if you have a component that is common across multiple applications, it allows you to take a dependency on a pre-existing threat model and you don't have to re-perform that effort. On the topic of effort, driving for consistency allows you to estimate your efforts more accurately. Estimating efforts is crucial to ensure that we allow for sufficient time within our delivery timeframes to perform the threat modeling exercise. Accurate effort estimation reduces the likelihood of causing a delay to the delivery of the business outcome. When you are consistent, you can use the historical data of how long threat modeling has taken in the past to inform estimations for the future. This consistency also allows developers and those involved in the threat modeling exercise to learn from existing threat models and allows them to work asynchronously across different time zones where they don't need to interact with each other in real time, because what they're looking at is familiar and consistent. Next up is you want to deeply integrate with your software development lifecycle and tooling. You should be treating threat modeling in terms of its activities and deliverables no different from any other project or software deliverable that you deliver as part of your SDLC. What this means is that you want to reuse your work management tools, your issue management tools, and put the activities for threat modeling on the sprint backlog just like any other deliverable. Equally, when you're collaborating on project outcomes, you are using existing collaboration tools, and you want to continue to use those tools to develop and deliver the artifacts that relate to threat modeling. Again, this allows you to work asynchronously and also allows the AppSec SME to be able to work across multiple reviews. Finally, you want to distribute ownership. There is a strong tendency to want to put all of the threat modeling activities with the person that's most well-versed in that area of expertise, which is generally our AppSec subject matter experts. But what we found is this really doesn't scale. These skills are hard to come by, and ultimately these individuals or teams become a bottleneck in the process. Instead, what we see work is that you have multiple streams of change across multiple teams within your organization, is that by putting the ownership of threat modeling with the developer allows you to scale that function and puts the ownership with those that are actually delivering the outcome. This frees up the AppSec SME to become an advisor, perform skills transfer, and really drive for that consistency that we spoke around earlier, around the methodology, the format, and the degree of decomposition. They are setting and raising the bar for security across the organization, together with your development teams are becoming your scaling mechanism. Now, let's go back to those three phases. You'll recall the very first question was, what are we building? So today, what we're building is a connected vehicle solution that will be used for fleet management. There are a number of functions within this application. There's vehicle registration. There is diagnostic error and trip data. There is telemetry data, which is telemetry data that's being sent from our connected vehicles up to our application running on AWS. There's also telemetry data that will be pushed through our analytics tools for anomaly detection as part of the ongoing assurance that the vehicles are operating within their baseline norms and that drivers are adhering to traffic laws. Now, this is a rather complex system that we're planning to build. So we really should be asking ourselves the question, can we decompose this? Can we break it down into smaller parts? You want to decompose to achieve speed to market, scale, and security. First, you want to align to your SDLC. What I mean is, the portion that you are threat modeling should be aligned to what you're delivering in your current project increment. So if you're delivering in a sprint, you should be decomposing your threat model down to the componentry that you're actually delivering in that sprint. Next, there's a tendency as humans that if we look for things in a smaller space, that we're able to discern more detail. What this results in is more detailed threat models that allows us to uncover more potential areas of improvement where we can mitigate additional threats. Earlier, when we spoke about consistency, we spoke about the advantage of reuse. One of the key enablers for reuse is to sufficiently decompose your application into smaller components. A good example is if you perform a threat model on your authentication system, and that authentication system is used across multiple of your applications, decomposing down to that level will allow you to reuse that threat model and effectively take a dependency on it. Finally, there is an opportunity that you could have layered mitigations. And what I mean by this is, if we're looking at mitigations for every decomposed area, if we zoom out and look at our application as a whole, it's quite possible that we've been mitigating the same threat at multiple points within our application, which really aligns to the principle of defense in depth. So with that, we should adjust our question to, what are we building this sprint? And in this hypothetical scenario, the user story is, as a vehicle fleet manager, I want to register a new vehicle and associate it with an owner. At the bottom, I've listed the various personas, and you'll notice that 2 of them are more prominent. What I'm depicting here is, whilst everyone is involved, the primary personas at this phase of what are we building are the business persona and the developer persona. So with that, what are we building this sprint? So it's this portion here at the bottom. Let me put it in the center of the screen. These are the components that make up the vehicle registration user story. What we have is a web browser that will be used by the fleet manager, AWS Amplify, which will contain the static assets like HTML, JavaScript, and CSS for rendering of the web page, Amazon Cognito with user pools for authentication, and the web application will use Amazon API Gateway to interact with the vehicle registration backend, which will be created using AWS Lambda and Amazon DynamoDB. We shouldn't forget that when we're looking at the components, it's oftentimes we need to look a little deeper. For example, our logs. Remember to think about both the primary and the secondary components, such as logging. What you want to do then is consider, what are the data flows between the components? Our very first data flow is our web browser to AWS Amplify to get those static assets. We have another flow for authentication to Cognito. Then we have another flow, which is where we go to API Gateway to interact with that vehicle registration API, where we'll be providing inputs to the API, including the vehicle VIN number, and we'll be getting a response from the backend, including success or failure, the vehicle ID, and the odometer reading of that vehicle. There are a number of other flows here which are related to logs and metadata. Now that we know what we're building this sprint, we need to go to the next question. What can go wrong? The very first thing to note is that there is no canonical list of what can go wrong. It requires brainstorming and collaboration between all of the individuals in our team and our various personas. The prominent personas in what can go wrong are the adversary persona and the developer persona. We'll be taking inputs based on what we created the diagram for, which are, what are we building this sprint, which includes our design, data flows, and entry points. We'll be thinking about what can go wrong, and we'll be aiding our brainstorming by using a mnemonic, something like STRIDE, which tells us the different categories we should be thinking about when considering what can go wrong. This can include spoofing or tampering or information disclosure. You may also want to look at the existing threat lists that are out there. Again, there is no canonical list of what can go wrong, but there are some existing lists out there to get some inspiration. For example, the OWASP Top 10, which is the top 10 most common web vulnerabilities, or the HITRUST threat catalog, or potentially your organization's own threat catalog, and I'll come back to that later. Finally, you'll want to think about, who are the actors? Are they internal or external? What are their motivations and what are their goals? And you'll want to be taking all of these inputs and performing the threat modeling exercise following the data flows. Now, you'll want to be able to answer the question, what are we going to do about it? Again, there is no canonical list of all the possible mitigations. Again, this requires brainstorming and collaboration between all of the personas involved. The inputs to this process are the identified threats, actors, and areas of improvement from the previous what can go wrong step. You then consider your own code that you're writing and its code dependencies, and you'll think about the software controls that you could put in place to address those threats. These could be things like input validation, session handling, or bounds handling. We find that the majority of where vulnerabilities are being introduced is within this area of custom code. So do focus very strongly on this area. For where you're using AWS services, you can consider using additional security controls provided by the AWS service. These are along areas such as data protection and logging and monitoring. Before we go deeper on that, it's important to understand that when we ask, what are we going to do about it, we should also be asking ourselves, who is responsible for doing something about it? With AWS, security and compliance is a shared responsibility between AWS and you as our customers. AWS takes care of what we call security of the cloud, which is the orange portion here at the bottom. This is our global infrastructure, our data centers, our availability zones, our compute and storage platforms, and everything up to the hypervisor level. For the portion on top in blue, that is your responsibility as our customer and what we call security in the cloud. Here you get to make choices like, which operating systems do I use? What firewall rules should I be putting in place? Who should have access to this data? And should I be encrypting this data? With all of those choices come the associated responsibilities. That shared responsibility model I've shown you is very indicative of what we will classify as infrastructure services. These are services like Amazon EC2, which are virtual servers in the cloud, be it Windows, Linux, or Mac OS. AWS takes responsibility of everything from the global infrastructure up to the hypervisor level, and you as a customer would choose an operating system, and with that choice, you would need to lifecycle and patch that operating system and all components above it. Which means you are considering the threat mitigations for those components that are within your portion of the shared responsibility model. We have other services that fall into different categories. We have what we call container services. For example, AWS Fargate, which is serverless compute for containers, but also other managed services like Amazon RDS, our relational database service, where we don't expose an operating system to you. Therefore, the threat mitigations regarding the operating system lies with us. Instead, what we do is we expose a database engine to you, and provided that you provide us a maintenance window, we'll patch it for you. Meaning that AWS is taking on more of the responsibility, and more of the threat mitigations are handled by us. In the most extreme case, we have abstracted services. A really good example is Amazon S3, which is a highly durable object storage service. In these examples, there is no operating system exposed to you. There's no database engine or any other platform for you to interact with in order to patch or manage. You do not need to perform penetration testing or vulnerability management of the AWS service. That is all on the AWS side of the shared responsibility model. And equally, all of those portions that are on AWS responsibility, the threat mitigations are managed by AWS too. So if we look at the spectrum from left to right, the infrastructure services, it's more customizable, but there's also far more responsibility on you, including the responsibility to mitigate threats in those responsibility areas. On the other end of the spectrum, with abstracted services, it's less customizable, but also less responsibility for you and more threat mitigation coverage is on the AWS side of the shared responsibility model. What is important to understand is that we don't simply ask that you trust that we do good things on our side of the shared responsibility model. Instead, what we do is invest in our compliance programs. AWS participates in over 50 different compliance programs where we are audited by third-party independent auditors. These compliance programs include SOC 1, 2, and 3, ISO 27001, PCI DSS for the payment card industry, and IRAP for here in Australia, and there are many more. The audit reports are made available to AWS customers free of charge via the AWS Artifact service. You can have confidence that we're being continually audited against globally and regionally relevant compliance standards. For the portion that's your responsibility, there are a number of resources that we provide to you. We'll be touching on two of them. The first is AWS Well-Architected program. This is taking our best practice guidance in terms of how you architect for the cloud across 5 different pillars, namely operational excellence, performance, reliability, cost optimization, and of course, security. And you will use these to guide your architectural decisions to adhere to what we consider to be the best practices. More specific to AWS services, we have a dedicated security chapter for the majority of our AWS services. These are really powerful when you're looking at security controls and mitigations that you may want to implement on a per AWS service level. Here I've put up an example for Amazon API Gateway, where you can see there are topics ranging from data protection to logging and monitoring and vulnerability analysis. So with that background, let's go back to where we were. This is the what are we building the sprint diagram, including all of our data flows. And what we're going to do is do a walkthrough of what a threat modeling exercise could look like and the conversations that are occurring between the various personas. What I'm going to do, given our time, is I'm going to scope it down to this portion, which is really the interactions with AWS Amplify for our web assets, our authentication against Cognito, and API interactions with API Gateway. So I'll give an example conversation. Here we have the adversary persona looking at Dataflow 2 to Cognito. And he's wondering whether or not he could perform a brute force or dictionary attack to authenticate against an existing user. They are considering what could go wrong. Our defender persona has done some research, and they've found that the Cognito user pools provide brute force mitigations using throttling, and has provided a link to the security chapter of the Cognito documentation that goes into some depth on how that works. The adversary persona accepts that this drastically reduces the effectiveness of brute forcing, but posed a secondary question asking if I used a breached credential list, something that I could purchase from a dark web marketplace, and I targeted a specific user. The defender persona recognizes that this is a good point and suggests they could enable multi-factor authentication as well as enable the compromised credential protection feature of Cognito Advanced Security. With this suggestion, the multi-factor authentication would mitigate this threat, as even if the username and password were successful, the attacker would not have access to the multi-factor authentication code or device. Then they had thought even further by saying if they enabled the compromised credential protection feature, this would prevent a user from selecting a password that's been part of a known credential dump in the past. They were layering their mitigations. Now we have the business persona chiming in, suggesting that whilst they're very much in favor of the protections being provided by multi-factor authentication, they recognize that this could introduce some friction for the end user, and they're a little bit concerned about that. The developer persona has found that with Cognito Advanced Security feature, you can choose to use adaptive authentication, where multi-factor authentication would only be required on a heightened risk level. So here we can see us taking into account the business view to get a balanced outcome. Two more examples to go. Here we have the adversary persona looking at Dataflow 3, which is the web browser to Amazon API Gateway. They're looking at it from a denial of service perspective, asking, could I cause a denial of service by overwhelming the entry point with requests? The defender finds that API Gateway actually automatically provides DDoS protection for counterfeit requests as part of the managed service. Here we have a good example of a security advantage of using AWS services that have more coverage in the AWS side of the shared responsibility model. The adversary then wonders, what if they're an authenticated user? Could they overwhelm the API and backend instead? The defender persona finds that they could implement API request throttling on Amazon API Gateway, but they would need to determine what levels they would want to throttle it to in terms of both the rate, which is the requests per second, and the burst levels. It's here that the business persona is able to lean in again and advise the defender that they have some volume projections of how many users they expect and what kind of rate of transactions. This is again a valuable interaction between the various personas, coming up with a balance of both security and business outcomes. The developer informs everyone that API Gateway supports native integration with AWS Web Application Firewall, and they may want to consider using AWS WAF for other web-related threats on this API. Okay, final example. Again, we're going to look at Dataflow 3. The adversary is wondering whether or not the error messages within the application that the developers intend to write potentially have information leakage in them that would be helpful for them to formulate other attacks. The defender persona states that they have considered this and they are using an internally developed node package for the generation of these error messages, designed to make sure that they are minimal. They've also pointed to the package source code, which is available in the source code repository. Our AppSec SME persona has come in and said, it's really great that you're using this package, and in fact that they were part of the threat model review when it was being designed. So here we're seeing an example of by taking a dependency on something that has already been decomposed and threat modeled, in this case, an application package for minimalist error messages, is that it reduces the amount of effort and scope. The developer persona recognizes that this package is the right package to use, but they need to ensure that they use it across all code paths that generate error messages in the application. So they've decided to include verification of that as part of their code review. The AppSec SME persona is thinking even further ahead and decides it's a good candidate to include in the penetration testing scope for this feature. So here we're taking a multi-pronged approach, using a threat model and vetted software package, code review to ensure a second developer verifies that the package is being used where it should be, and as a final check, we will ensure as part of our penetration test that this is validated. We have looked at a very small sample of the kind of conversations that could occur as part of the what can go wrong and what are we going to do about it steps. Naturally, one of the questions we always have to ask ourselves when talking about threat modeling and mitigations is, when is enough enough? Threat modeling is really risk analysis, which requires both likelihood and impact to be duly considered. Why I suggest that you have all these different personas in place is that there's a deliberate and natural tension between all these personas to find that right balance. You do not want to over-index towards let's just ship it. And equally, you don't want to over-index towards over-analysis and being unduly concerned that you've missed something. Finding that balance really is what the aim should be. And that can be achieved by leveraging and embracing that natural tension between all of these personas. With that, you would want to consider what's next. The AppSec SME persona would be reviewing and endorsing the various threats and mitigations that were identified, looking to raise the bar. Were there threats or mitigations that were missed? They would be reviewing the existing mitigations, both in code and in CloudFormation in the case of infrastructure as code. They would also be reviewing and endorsing the proposed mitigations. The developer would take the role of delivering the agreed mitigations and ensuring the code review process is adhered to. Back to our AppSec SME persona, they'll be setting the security deliverables and acceptance criteria for the remainder of the delivery phases. For example, penetration testing scope is largely based off the findings from the threat modeling exercise. Now, it's time to take a step back from focusing on what we're building this sprint and start thinking about how we can take what we've learned and scale it across the organization. The AppSec SME persona has an opportunity to look at the threats that are identified for this decomposed feature, and they'll be able to ask themselves the question, could we contribute this to our organizational threat list so that others could use it as an input into what could go wrong? Could we take the mitigations that we've identified through this process and add them to an organization's mitigations list so that the others could use it as an input into what are we going to do about it? And importantly, thinking big, they'll be considering which mitigations we found here could potentially become baseline security controls for the organizations implemented at the platform level. For example, perhaps the advanced security feature of Cognito should be enforced as a baseline security control for this organization. This starts to put in place organizational protections and mitigations and reduce the amount of per workload or per feature mitigations that need to be put in place. So, to recap, you really want to invest time to set your organization up for success. Assemble the right team, drive for that consistency, integrate deeply with your SDLC and tooling, and distribute the ownership. Then, focus on the present rather than the past. Focus on what you're currently designing and what's coming up in your backlog. Don't let paralysis stop you before you start. Start now. Adjust, iterate, and improve. One last thing to leave you with, AWS security skills are in very high demand across the industry. There are some really great courses you can take with AWS, some of which are free of charge, for example, the AWS Security Fundamentals. Or you can go deeper with classroom training, which is also available for virtual delivery. Or to really show your skill by achieving the AWS Certified Security Specialty certification. I encourage you to visit aws.training/security to learn more. And with that, thank you for watching, and please give your feedback by completing the session survey.